Hi everyone, my name is Jimmy. Here I will share our publication with title Payoffs and Pitfalls in Using Knowledge Bases for Consumer Health Search. The domain of my talk today is consumer health search. With consumer health search, we mean the search tasks where common people, like most of us, search web for health advice. This is a very common activity. However, the problem that we want to address here is that people are not effective in formulating health search queries. People often submit underspecified and ambiguous queries based on observation of symptoms. On the other hand, the current search engine struggle to retrieve search results that are relevant to such queries. To understand problems in formulating health queries, imagine this. Imagine if we observe this condition. We have no idea what it is, and therefore, we decide to Google this health condition. How can we Google this? A study of consumer health search queries finds that for this exhibit, people submit query using layman language such as swollen legs. A more effective query for this should be edema, which is the precise medical term for this condition. This inspires a question: how can we improve a user query into a more effective one? In this study, we investigate query reformulation methods to improve the effectiveness of initial queries. A previous study by Plotnik and Chen shows that manually replace layman terms with medical terms lead to a more accurate search result. We therefore question, can this improvement be done automatically? To automatically improve health queries, in this study, we investigate the entity query feature expansion model. This model has been known to be effective in clarifying a user query by adding related entities from knowledge base such as Wikipedia. However, in their study, they are working for general domain study. Hence, here we investigate whether this EQFE can be applied to improve the effectiveness of consumer health search queries. This model, this EQFE model, is formally defined as the sum of expansion terms across all entity mentioned mapping M to all knowledge-based entity features F. In this study, we consider three knowledge bases: the Wikipedia, the UMLS. UMLS is a compendium of thesaurus in medical domain. And the third one that we consider is the Consumer Health Vocabulary, or CHSpeople in short. For Wikipedia, we extracted the title, the categories, links, aliases, and body in each Wikipedia page to be the features of an entity in Wikipedia knowledge bases. For UMLS and CHSpeople knowledge bases, we exploited the title, aliases, body, parent, and related entities as features of an entity in these two knowledge bases. We divided the implementation of EQFE into 5 consecutive steps. Each step involves multiple choices. The first step is knowledge-based construction. In this step, we consider which entities to be included in each knowledge bases. The second step is entity mention extraction, where we extract entity mention from the user query. For example, if the user query for a headache caused by high blood pressure, we extract entity mentions such as high blood pressure, headaches, and so on. Third, we map the extracted entity mention to entities in the knowledge base. Fourth, we investigate the best source of expansion term from the knowledge base. The last step, or the fifth step, we consider relevance feedback methods to further improve the effectiveness of the already expanded queries. For our experiment, we use the CLAY 2016 eHealth task, which consists of 300 queries, and the CLUEP 12b corpus. We evaluate results based on NDCG at 10, BPREF, and RBP at 10. Each choice's effectiveness was measured sequentially and used to determine the subsequent steps setting. The best setting of each choice was determined based on average results for all query sets. However, if there's a discrepancy, then we check results from the high coverage queries. What is the high coverage queries? I will explain about that one a bit later. Now, let's start with choices for step 1, which is the knowledge-based construction. In this step, for Wikipedia, we consider 4 options. All Wikipedia pages, pages containing medicine info box types, pages containing medicine info book types and links to medical terminologies, and the 4th, we consider only pages with title matching UMLS entities. For UMLS and CSV, we consider using all entities and using only entities that are related to symptoms, diagnostic texts, and treatments. Our initial results showed that the expanded queries retrieve many unjudged documents. As shown in this plot, the majority of baseline queries without expansion terms retrieve less than 2 unjudged documents in the top 10 result. In contrast, the majority of expanded queries retrieve more than 5 unjudged documents in the top 10. This is a problem, as commonly unjudged documents are regarded as not relevant to the query. To enable a more fair comparison, we also consider high coverage queries, which on average across all considered choices have a maximum of 2 unjudged documents. Now let's take a look at results from all choices that we considered in step 1. This plot shows effectiveness of queries expanded using Wikipedia knowledge bases. The dark colored bar, the one at the bottom, are average of all queries, and the light colored bars, the one on top, are the average of high coverage queries. For comparison, the effectiveness of baseline queries or queries without expansion terms are displayed as dashed horizontal lines. Like the yellow dashed line are baseline from high coverage queries. The red one are baseline from all queries. Based on the 3 plots that we see that option WC type links performs better than other options across all 3 measures. As you can see here, this one is better, higher than the other options. This one is also type links, and based on RBP at 10, type links also the best. Therefore, WC type links will be used for the subsequent experiments. We do the same analysis for queries expanded using UMLS and CSV. Results shows that UCO is the best for UMLS-based queries, and CCMAT is the best for CSV-based queries. For choice 2, we consider 3 entity mention extraction methods. First, we consider all uni, bi, and trigrams. Second, we consider grams that match CSV entities. Third, we consider grams that match UMLS. And fourth, we consider grams that match UMLS using MetaMap. Results from option 2, for step 2, suggest that WME, CSV, UME, UMLS, and CME, CSV are the best, and hence, they will be used for the subsequent experiments. For choice 3, entity mapping, we try to match entity in a query to entities in a knowledge base based on their features. As I mentioned earlier, each knowledge base has its own set of features. For example, for Wikipedia knowledge bases, we consider mapping to title, aliases, links, body, categories, and all of these 5 features, which is the all option over here. Results from step 3 shows that mapping using the aliases is best across all knowledge bases. In step 4, we consider features of knowledge base that are best to be added as expansion term. For all knowledge bases, we consider adding the title, the alias, and both the title and the aliases. Our results indicate that the best features to be added as expansion terms is the title. This is true across all 3 knowledge bases. Additionally, in this study, we also consider the effectiveness of combining expansion terms from multiple knowledge bases. So instead of considering expansion terms from individual single knowledge base, we try to combine these expansion terms. We find that the best is the combination of expansion terms from the Wikipedia and CHSpeople. We call this combination as Wiki-CHSpeople. The final step, we consider relevance feedback and pseudo-relevance feedback. In this step, we also investigate the effectiveness of filtering expansion terms to include only terms with high probability of being health related. This is suggested by Soldaini et al. In 2015. Results suggest that relevance feedback with health terminology filter is best across knowledge bases. Our empirical investigation indicates that the best settings of each knowledge base that we consider in this study are effective to improve the effectiveness of user initial queries across 3 measures, which is the RBP-10, NDCG-10, and BPREF. So in this plot, we stress the improvements of best settings over the baseline. So we can see here, according to the RBP-10 measures, the expanded queries improve like more than 80% across from the baseline. To evaluate the generalizability of our findings, we have applied these best settings against CLAY 2017 tasks, and we also evaluate using shallow evaluation methods. We found that the results are similar to this one. In conclusion, we found that knowledge base can be used to automatically improve health search queries, leading to a more precise top-ranked search results. However, there are caveats or pitfalls with the settings of knowledge base that needs to be fine-tuned before the payoffs can be harvested. Thank you for watching.